From the heart of preLights, the preprint highlighting service run by early career researchers and supported by the Company of Biologists, this is spotLights.
Hello and welcome to Spotlights, the preLights podcast that highlights the stories behind the most exciting biological preprints, putting the spotlight on the early career researcher behind the preprinted work. My name is Ethan, joined by Philip and Sriya, and we'll be your host today. In this episode, we're joined by Jan Engler from the Institute for Neuroimmunology and Multiple Sclerosis of the University Medical Center Hamburg-Eppendorf. Today, we'll be discussing his preprint, Tidyplot Empower Life Scientists with Easy Code-Based Data Visualization. Thank you for joining us, Jane. Let me start with the first questions. I'm curious how you got started in science and how did you get to where you are today?
Yeah, very happy to be here. Thank you for the invitation. So how did it all start? So initially, I started studying medicine in Berlin at the Charité. And at the time, I was really enjoying the first part of the studies, which were basically about basic science and biology and physiology and anatomy. And after the first 2 years, there's a cut, there's a big exam, and then it goes into the clinic, and then everything becomes more towards actually treating patients, but also it becomes a lot more less about the underlying mechanisms or how it all works. It's more about which signs, when they show up together, define a certain disease and what do we do? And then in Berlin, I decided to, start an MD thesis in rheumatology. This was about immune regulation and basically about the question, why is the immune system reacting towards the own body and how does this come about? And this was in systemic lupus erythematosus, my work. And then after finishing my studies, I looked around and found an institute in Hamburg where I'm still working, the Institute of Neuroimmunology, where they had the opportunity to still work on immune regulation, and this time in pregnancy, and to learn more about how actually pregnancy is really, really interesting for immune regulation, because the fetus is basically like a transplanted organ, if you wish. And and they were interested in autoimmunity and what can we learn from pregnancy to maybe better treat autoimmunity. Yeah, and this is how I ended up in science.
That's awesome. So I guess your main focus, your day job is focusing on immunology. And what motivates you to develop Tidyplots then?
Yeah, actually, it's not that continuous. So I always pick something new. I have the impression. So I started with immunology here. At some point, I was switching gears a little bit more to systems biology and neurobiology, and then also to and now in recent days more into developing tools. And how did this come about? So we are using ggplot and the tidyverse a lot in the lab, and we teach this to every PhD student or master student who comes in the lab. And and therefore we actually realized where are the problems when learning it and also when just doing it. So what are the parts that are always difficult to do? Because you need a lot of code, or you need to know really detailed about one specific concept that is maybe in itself not really interesting, but you need to understand it in order to this one plot. And in the beginning, I just collected this stuff in one big helper package. And then it grew and grew. And at some point I thought, okay, maybe this is something that could be interesting also for other people.
Yeah. And that's what I was thinking as a regular user of our statistical software. My question comes in the way that how is it that you would advise someone who's not used to the interface of art, which may seem intimidating for a lot of people? We all know that art isn't like a graphical interface that is very pleasant to other users. But how would you advise people to embrace the system, and what's the way that you have to make them believe that it's a better alternative to other maybe commercial software that we are all used to working with. And yeah, basically that's how would you convince people that they should start choosing open source software for this kind of purposes?
Yeah, I mean, that's a good question, and maybe also a constant struggle. So everybody, of course, likes to pick his or her own tools. So you don't want to let somebody else tell you what to use. I totally respect this. I think the strength of using code-based data visualization is that it's more reproducible, and it's also sometimes or oftentimes a lot more productive, because you can really experiment with how you want to show the data. And this is much easier because, yeah, it's all based on code, and you can run it over and over again. And in the end, if you do the experiment a second time, and the only thing that really changed was the data table at the very start, you can just run the script and you have the plot without going in Excel, copying, pasting stuff, applying formulas, doing some copy and paste mistakes in the meanwhile, and then wondering why it looks odd. And yeah, all this stuff is gone when you just have a script. But then I also have to say that also when I was preparing figures for papers, I was going back and forth a little bit. Sometimes in one paper, I remember I did everything in ggplot, and then I was fed up after doing this, because this in the end was also complicated, because for each little tiny figure where you just have two groups and then an n of 7 in each group, you have to write a whole script and have the data table for this. And this was also a big overhead. And then I was going back in the next paper to Prism. This is what we have in the lab. And yeah, which was for this kind of stuff much easier. I think it really, really shines when you have more complex data. When you just compare two different groups and you want a scatter plot of this, then I think it's fine to do this also with a graphical user interface. There's not so much stuff to play around with.
I was considering this when I showed the Tidyplots package to my lab mates, and it seems that some people, starting from the basic scientific method, really forget about visualizing data before doing anything with the data. How do you approach to this problem? Maybe with new scientists coming to the lab, early PhD students. Have you find that neuroscientists, early generations, have been less and less interested in visualizing the data, understanding how the distribution of the data is, and just clicking and go ahead with whatever statistical analysis comes, and just looking for the p-value? Because I think that's something that common software is usually hiding in the steps.
I don't know. Maybe that this just comes also with some time and with more experience. Yeah, and then the data have to represent the experiment that you did. And actually, it starts earlier when you set up the experiment and you think about, okay, what do I want to show, and how can I show it by doing which kind of experiment? And then this usually also guides the visualization in the end. And I think I still like a lot experiments that only have two groups in the end, because it's simple. So if it's possible to do that, go for it. In the supplements, you of course you have to do all the controls in the end, but I think this is still something to strive for, to have simple. So don't do visualization because you want to do visualization. So try to communicate something.
Yeah, and just by looking at how Tidyplots works, it really shows that you took care on using natural language for understanding how to modify the figures, and that's very helpful for someone who's already been working a lot of time with ggplots, and you know that you have to go specifically doing the aesthetics for each part of the figure. But Tidyplots really comes up with this very clever solution that is the use of a more natural language to modify that part. So it's very helpful.
Yeah, I mean that's cool. If it works in the end, that's really cool. So I really love ggplot. I mean, this is what I was using a lot, and I was also really hesitant to like put something out there and then saying, okay, this could be like an alternative or like a meta level. But still, I found that there was room for shortcuts, and this is how the package started with these little wrapper functions. And then there's also quite a few concepts that I think are quite complicated, or I mean, at least when you use factor levels, you have to know about factor levels and how they work in order to reorder labels on an x-axis. And this is not necessary in a way to know about factor levels. Then R people will say, okay, but you have to know about factor levels anyway, because it's at the heart of the R programming language to understand what they are. But this was a little bit the sense of, or the idea also of of Tidyplots to take out as much prior knowledge as possible. Another thing is scales are quite powerful, or guides, and how they work, but they are also complicated and you have to understand them. And I try to like maneuver around these things a little bit. And then I think what Tidyplots comes down to are basically three verbs. It's just add, remove, and adjust. These are the three main verbs. And the idea is just when you have a plot in front of you, what are the most likely things you want to do? Either you want to put something on top of it, you want to get rid of something, or you want to tweak something that's already there.
Yeah, that's exactly what I thought. Like, it has the basic input that you most usually use, like modifying the axis, like putting something here, putting something there, just getting rid of something, or just adding something else. So it's very helpful.
I have a question on the aesthetics of the Tidyplots. Do you have other color schemes of doing your data? Because here I see 5 colors, but like maybe I have like 10 or 15 data sets and I need to plot them in the same plot. Do you have other color schemes, or how do you come up with other colors? Is there an option there?
Sure. I mean, there are quite a few color schemes built into Tidyplots that you can use. And the one that's the standard is, I call it friendly, because it's friendly for people with color vision deficiency. But I mean, there are quite a few. So in Tidyplots, they start all with colors and then colors underscore, and then you can choose between discrete or continuous or diverging. And then I think there are 5 or 6 color schemes for each of these different groups. And of course, you can also do your own color schemes. Just put the hex values of the colors in there. And I think this is also something that really is seen in good papers or in good figures, that you have a consistent color scheme, or you think about what should colors represent, and then really stick to it across the different panels, but ideally also across the different figures, so that you really have color as a guidance for the whole story, basically. I think this is something to strive for.
I have a last question for me, but, so earlier you touched on the biggest hurdle that you see is the initial stage where, get the data set ready for the program to read, right? So do you think there will be a way to reduce that hurdle?
So I think this is something that's also working with a code-based approach. And then in general, how to make data wrangling easier. I think the dplyr package in the Tidyverse is really great to do this. It's also really powerful functions. Also a little bit complicated to understand how pivot longer or pivot wider really work. It takes a little bit time to get used to it. So I was thinking about how to get rid of this altogether. So I I had the idea to maybe build a new package like tidy data, where you just plot in the raw data and you get your tidy tibble out of this. And I did some experimenting with it, but it's hard. But I think now is the time maybe to try this. Also using, of course, large language models, but then you have to do this in a way that is reproducible. So you cannot give the data to the large language model and then say, give me the tidy tibble, and it gives you something, and then you have no idea whether this is right or wrong. So this is something you cannot do in science. So yeah, but this is also something I'm not the perfect person to tackle this question, but definitely something I'm interested in.
Great. Looking forward. Thank you, Jane. That's it for this episode of Spotlight. We'll see you next time.